Today we're going to talk about how to name ions and the different conventions between naming a metal ion and a nonmetal ion. So just as a reminder, uh, we do know that we have this stair-step line that goes right here on a periodic table. And the importance of this stair-step line is that it separates our metals to the left from our nonmetals to the right. And so that's an important idea because there's different naming conventions for metals and there's different naming conventions for nonmetals. And we'll separate out the naming conventions for the transition metals in a little bit. So we're going to first talk about naming metal ions in group 1A, 2A, and 3A only. We will come back to the transition metals later. And so remember 1A right here, and these are all going to form a charge of 1 plus, and those are going to lose 1 electron. 2A, those alkali earth metals are going to form a 2 plus charge by losing 2 electrons. And then over here we have 3A, and these are going to form a 3 plus. These are all going to lose 3 electrons when they form ions. And so the naming conventions of these guys is very easy. We just call it the name of the element. So for example, let's say right here, if we had Na1 plus, we would just call this the sodium ion. Or if we had Al, it would be called the aluminum ion. That would be aluminum with a 3 plus charge. Let's rewrite that actually with a symbol. Al, 3 plus. So those guys are really easy. Now, again, when we get into our transition metals, which are located here, these are all going to have they will have a different type of naming convention, and we'll get to that in a little bit here. Now, down to our non-metal groups, and there is a typo there, that should be non-metal ions. And these are going to be group 5A, 6A, and 7A. So kind of scrolling back up here, we are talking about group 5A, that nitrogen group, which is going to be a 3 minus, gaining 3 electrons. 6A, which is going to be our oxygen group, is going to be a 2 minus. And 7A, those halogens, a 1 minus. These guys have different naming conventions. So what we're going to do with our non-metal ions is, let's take O2 minus right now. Now this is oxygen. And what happens when we name nonmetals is we are going to drop the ending of the word. So we drop the ending of the word, and we're going to add the suffix IDE. That tells us that we have a nonmetal ion. So oxygen becomes oxide. Oxide tells us we have O2 minus. Throw another one at you just for the fun of it. We have I1 minus, which would be iodine. And so again, we're going to drop that ending of the word, and we're going to call it iodide. Oftentimes you'll see me underline that ending, as later down the road we're going to change some of those endings when we get into a little bit more complex ions. Now, here's a couple practice problems here. And so if you would like to stop the video now or pause the video and just do these problems and then come back and check your answers, you're more than welcome to. But we're going to name the following ions, and I'm going to kind of walk you through it here. So go ahead and pause the video if you'd like to. Okay, so this very first one, we have Ca2+. Now, we have to remember that this is a metal ion, and so we're just going to call it the calcium ion. On this next one, we have P3-. This is a nonmetal ion, so what we have to do is we have to drop the ending of phosphorus and add that IDE suffix. We're going to call that phosphide. Our next one, we have F1-, which is also a nonmetal. And so we are going to call this guy, this is fluorine. So we're going to call that fluoride. And you probably recognize fluoride as one of the ions that's present in toothpaste. And it's usually in the form of sodium fluoride. And the last one is Li1+. This is a metal. we're just going to call it the lithium ion. Notice we did not add the IDE suffix there, as it's a metal ion, so we just call it the name of the ion. Okay, and that is how we name ions, whether they're metals or nonmetals, and we will get to naming of our transition metals later on.